First atomic nuclei in the process. Nucleosynthesis formed less than a second after the Big Bang. First there was neutron. Then it decayed into a proton and an electron, which together formed the atom of the simplest hydrogen. Some of the protons combined with neutrons to form deuterium nuclei, heavy stable isotope of hydrogen. It happened already at the 10th second, from the emergence of spacetime, in which we exist. What about lithium? When the temperature and density of the universe have decreased to a certain limit, high-energy protons disappeared, which broke proton-neutron bonds. All the deuterons broke into pairs and formed nuclei, main isotopes of helium. It was already the 20th minute since the birth of the universe, and its density dropped so much that atomic nuclei could accelerate to such speeds that merged during the collision. Some strengthening of the nuclei produced heavier elements and flood with atomic masses 6 and 7. Abirans with atomic mass 7. The latter decayed and turned into lithium. All those primary nuclei appeared after the Big Bang, became the raw material in the depths of stars for thermonuclear fusion, and all of them were spent, but only gels and were synthesized from hydrogen, and was consumed and formed heavier elements. Because scientists didn't know what reactions did lithium form, they all thought that its quantity should also decrease. Then there should be very little of it in outer space, such as the same deuterium. Earlier stars should have contained more lithium than in those that formed later. However, spectral observation data showed that everything is the other way around. The concentration of lithium is higher in those luminaries. What is younger is called the lithium problem, or the lithium paradox. Scientists have begun to analyze the substance of space. Rays of atomic nuclei, which fly at enormous speeds. It turned out that when they collide they can break into different pieces, masses of nuclei of other atoms. There was also some lithium there, although not enough for that to explain its existence. But in the 80s of the last century, giants were discovered, lithium enriched. When a solar-type star completes its life cycle, the hydrogen in its depths has almost turned into helium, and she starts to warm up from the launched thermonuclear fusion and increase in size, turning into a red giant. Astronomers know quite a lot of such stars, because they are visible even at great distances, due to its high luminosity. 1% of red giants contain such a substance in their depths. Lithium concentration, which is hundreds and even 1,000 times, exceeds the results of calculations on the evolution of stars. For example, the star TIC 429-20971 has the highest lithium level among its known counterparts, 451/100, which is 1,000 times higher than standard values. However, it remains unclear what processes generate so much lithium. What is known for sure? So this is what these processes are triggering. In a protostellar gas field cloud, forming a star, certain heavy elements. And when is the red lithium giant will begin to turn into a white dwarf? It will throw its outer shell into the surrounding space. Then it will enrich it with lithium. He in turn will become one of the components of interstellar matter. And he will get a chance, become part of the next generation of stars and planets. According to a previously existing hypothesis, the high lithium concentration was a result of that some external source polluted space with it. For example, if a brown dwarf or a gas giant like Jupiter encountered not so hot or protostar, but for example, UR 429-20971, containing an abnormally high amount of this metal, shows the inconsistency of this theory, since the supply of lithium in external sources is limited. The paradox can only be resolved own lithium production. Scientists, based on data collected from TIC 429-20971, built a computer model showing which process is responsible for this. Lithium content. The synthesis of this metal in the depths of the star determines the mechanism of the camera on the Fowler. This happens because that atom beryllium is synthesized from helium there, where the temperature is too high for lithium. Convection brings beryllium to the surface, and in colder conditions it turns into lithium. For this to happen in the star giants, more intensive mixing of layers is required. Of course, all the results obtained require additional observations and research before making any definite conclusions. In general lithium formation processes. Sphere.